Now, the second question was about independence, runs scoring by inning independence. Looking at independence, let's define it a little bit better in baseball. And what independence implies, kind of like the independence of a coin flip or the independence of rolling dice, it implies that the distribution of runs scoring across the game is unaffected by the other scoring going on. So there's ways to test this. There's this idea of the lucky seventh inning. After the seventh inning stretch, the home crowd implores the home team to score runs in the seventh inning. There's the idea that the ninth inning isn't independent and a run scoring chance like any other because strategy changes. Not extra innings for the same reason. It might be a little different. So what you're implying here is that it's not an even coin, or it's not an even set of dice. They're loaded somehow for certain situations. Other things to check are total runs scored. Does total run scoring look like what you'd expect if you always just flipped a coin every half inning and got the probability of scoring a run to be what you'd expect on average? And the other question here is leads. Do leads affect things? Are there the right number of lead changes? Are the right number of leads accumulating? So that's what Lindsay does. He checks out different scenarios in the game to see if this run scoring in a half inning is a lot like a coin flip. It just happens with normal independence. So how does he check this? Well, here's a graph showing the solid line here is if these runs are independent in every half inning, the distributions of runs scored over the whole game by one team follows the solid line here. In other words, there's a certain probability that you would score 0 runs based on, the string of coin flips throughout the game. There's a certain probability that you would score 3 runs based on the string of coin flips throughout the game, all the way up through larger run scoring chances, over 10 runs, 11 runs, 12 runs. That's all here. This section of the graph is blown up after 10 innings. It blew up this section of the this smaller lower section of the curve is blown up here. So, is it like a coin flip that way? The probability of scoring a run in any half inning leading to the total number of runs scored. Well, there's a couple differences here. For some reason, the 5 runs scoring here is low in the 1958 sample. There's another sample here at 11, which looks a little high for the 1959 sample. But you look at the other years, and it looks like it's more normal. So that probably gets balanced out with more power in combining these years. It's a little strange why Lindsay doesn't combine years in some of these analyses, but he must not have been able to based on how his data was structured. So, but the interesting thing here, the one result which seems to be true, is that after 10 runs, from 11 runs on, there seems to be more runs scored than normal. This little trend here is statistically significant. Let me color that trend here so we can see it. This little trend here is statistically significant. So right here, this area is more than normal. This is more than just a coin flip would predict. So somehow, large run scoring doesn't follow a rule of independence. Doesn't follow the rule of independence, this area on, which is interesting. So the number of extra inning games follows the model of independence just fine. In other words, running the coin flip, you get the number of extra inning games just like you'd expect. Lead changes and overcoming a lead show independence also. There's no observable tendency for the underdog to overcome leads more than you'd expect. They overcome leads like you would expect if you're running a coin flip model of run scoring. Now, the one thing here is runs over 10. Runs over 10 seem to happen by a team a lot more than normal. Runs over 10 happen a lot more than normal. And it's speculated by Lindsay that this is because managers, once they get a blowout, will keep that pitcher in, and maybe it causes more of a blowout because they keep the weak pitcher in who's not pitching so well. The batting team, the offense just scores lots and lots of runs, and the manager says, I'm not bringing in a new pitcher. So this was Lindsay's speculation about why there might be more significant large run scoring games than he predicted by his model. Okay. Here's another look at something similar. This is the final winning margins. Okay, this is looking at the final winning margins. Again, the black bars are from 1958. The white bars are from 1959. The winning margins based on his coin flip model of independence of run scoring by inning shows the line here. You'd expect a 30% of games being a one-run game, a two-run game would be about 18%, etc., all the way down the line. Now, the one thing that shows up here again is this is higher than you'd expect. The winning margins of greater than 10 runs should be very low probability, should be right around here, sort of following the trend of what he'd expect, but this comes above normal. In other words, again, winning margins greater than 10 runs shows up where you really wouldn't expect it to. So there's significant excess leads observed in the game than you'd expect by just modeling it independently. So this is where, again, over here, you talk about Lindsay's speculation. This could be due to leaving a poor pitcher in when the game is already lost. I'll make a note here that he reduces his statistical power by not combining years. Maybe there was a way to combine the data. Maybe there's a way to grab his data. Maybe there's a way to repeat the studies to see this again. Actually, repeating the study would probably be the best thing with better data. We have much more event information in the game, and we could probably reproduce this to see if this is the case. So again, two things show up that are not independent. Significant excess leads and runs scoring in innings that are greater than 10 runs. So note that there might be something here about managers leaving pitchers pitching poorly in games when they're completely lost.